Good morning, children. In today's class, we are going to learn about locus. Locus is a path traced by a moving point. Path. What do you mean by path? A point may go like this. Suppose we throw a point, it will go like this. There is a point here or here or here. No, it is keeping on moving. How to write the equation of the moving point? If it goes under some conditions, say here is a point is moving in such a way that it maintains a same distance from the point. This I will call a circle. As we see, the point is moving around in such a way that the distance from the fixed point is the same. Like this, I may give 2 points, say A and B. P is moving in such a way that the distance from A and B is always constant. These we call locus. How to derive the equation in each case? The moving point P, let us name as H, K. They will give you some condition. Say the distance is equal. I will write PA equals PB. The distance from O is constant. I will write OP equals to whatever constant they give in the question. In all these cases, I need to use distance formula. What is distance formula? Root of x1 minus x2 the whole square plus y1 minus y2 the whole square. You also have problems based on triangle, area of the triangle or centroid of the triangle. What is centroid formula? If I know 3 vertices, centroid is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Like this. What all we learned so far in geometry, we will recall and we will try to frame an equation in x and y. So the moving point I treat h, k. I use distance formula, area formula, centroid formula or whatever they give in the question and derive an equation in h, k. As P is moving, once I derive the answer, replace h by x and k by y and we get an equation like this. Such things I call locus. The path traced by the moving point in terms of an equation in x and y, where x, y are the coordinates of the moving point. Let us learn the exercise problems. Exercise 6.1, question number 1. Find the locus of P if for values of alpha. The coordinates of a moving point P is 9 cos alpha, 9 sin alpha. Second subdivision, 9 cos alpha, 6 sin alpha. Both the problems are almost the same pattern. How do we do it? Locus of P, as I read it, the point given, let us assume as h, k. Let h, k be the moving point. Then 9 cos alpha is h, 9 sin alpha is k. Similarly, here we write it. The next step. As I know, cos square alpha plus sin square alpha is 1 whenever the problem contains cos and sin. Try to find out what is cos alpha and what is sin alpha. So what is cos alpha from here? H by 9. What is sin alpha? K by 9. The same we do here also. The next step. We remember the idea cos square alpha plus sin square alpha is 1. Squaring and adding h square by 81 plus k square by 81. As I add, this answer is 1. So I can compare this is equal to 1. 81 the same in the denominator. We can cross multiply. So what is the equation? H square plus k square is 81. In this case, the two numbers are not same. So leave the answer like this itself. We need not cross multiply. But the last line, whenever they ask you locus, replace h by x and k by y and we get the required locus. Question number 2. Find the locus of a point P that moves at a constant distance of 2 from x-axis. This is x-axis. The point is moving in such a way that it maintains 2 distance from x-axis. As I see the diagram, I know very well it is a line parallel to x-axis. I can immediately write the answer. Any line parallel to x-axis is y equals constant and that is 2. So we are done. If you need to write in steps, consider the moving point P is h, k. Since it is making 2 units from x-axis, the y coordinate is always 2. K value is 2. K represents y value. To write the locus, replace h by x and k by y. So I get y equal to 2 is the locus. The second subdivision, they have given 3 units from y-axis. So here the point is moving in such a way that this distance is 3 all the time. Again, consider the moving point is h, k. Here x value is 1, 2, 3. So x value is 3 wherever we go. So we put h is equal to 3. To write the locus, replace h by x and k by y. Here we have only h. So h is x equals to 3 and that is the locus. Hence we have done the problem. Question number 3. If theta is a parameter, find the equation of the locus of a moving point whose coordinates are x is equal to a cos cube theta and y is equal to a sin cube theta. As soon as I see cos and sin in the question, I will remember the identity. Cos square theta plus sin square theta is 1, which will help me to find out the locus. From here, what is x by a? That is cos cube theta. Bring 3 to the other side. X by a whole power 1 by 3. Remember, power 3 in this side will go to the other side as reciprocal. That is 1 by 3. But I want cos square theta. Squaring on both the sides. Cos square theta equal to x by a whole power 1 by 3. The whole power 2. Or I will say x by a power 2 by 3. The same pattern here. Bring a to the left. Y by a equals sin cube theta. Same pattern. Bring 3 to the left. Y by a the whole power 1 by 3 equals sin theta. Squaring on both the sides. Sin square theta is y by a the whole power 2 by 3. Once I know what is cos square theta and sin square theta, let me remember the identity. Cos square theta plus sin square theta is 1. So add these two. X by a, the whole power 2 by 3 plus y by a, the whole power 2 by 3 equals 1. Leave the answer like this. Or one more step. Both the terms have the denominator a power 2 by 3 cross multiplying. So I can also write x power 2 by 3 plus y power 2 by 3 equals a power 2 by 3, and that is the locus of P. So given theta as a parameter, we have achieved an equation in x and y eliminating theta using the identity cos square theta plus sin square theta equals 1. Question number 4. Find the value of k and b if the points p minus 3, 1, q 2, b lie on the locus of x square minus 5x plus ky equals 0. Given the equation, call it as number 1. P minus 3, 1 lies on it. What do you mean by a point lies on some equation? It must satisfy that. Wherever x comes, put minus 3. I will write minus 3 the whole square, minus 5 into minus 3 plus k into, wherever y comes, put 1 equals to 0. Or we get 9 plus 15 plus k is 0, or k equals 15 plus 9, 24, goes to the right as minus 24. I have found out k value. The question is to achieve what is k and b. One answer is over. What else is given in the question? 2, b also lies on this. Let us substitute. X square, that is 2 square, minus 5 into 2 plus k into y value is b, that is equal to 0. Since we know what is k from here, I can very well substitute. This becomes 4 minus 10 minus 24 b equals 0. Minus 24 b equals 4 minus 10 is minus 6, goes to the right as plus 6. Or b equals 6 by minus 24, that is minus 1 by 4. So b value minus 1 by 4 and k value is minus 24. Question number 5. A straight rod of length 8 units. This is the rod. Slides with its ends A and B always on the x and y axis. So A keeps on moving like this, B keeps on coming like this, or B goes up, A goes here. So A is always on x axis, B is always on y axis. Find the locus of the midpoint. So let us assume whichever locus I want as h, k. What is this h, k? It is the midpoint of A and B. Where is A actually? On x-axis. Consider the length as A. If I take OA as A and OB the length as B, how will I write A as A, 0? Because it is on x-axis. How will I write B? 0, B, because it is on y-axis. How will I write the midpoint? We know the formula x1 plus x2 by 2, y1 plus y2 by 2. x1 plus x2 by 2, y1 plus y2 by 2. As I simplify, I get h equals, we know the middle point formula. We have assumed h comma k whenever I want the locus. So compare. H equals a by 2, k equals b by 2. Cross multiplying, 2h is a and 2k is b. But OAB is a right angle triangle since x-axis and y-axis are always at right angles. In a right angle triangle, we can very well remember Pythagoras theorem. OA squared plus OB squared equals AB squared. OA is A, OB is B. So I will write A square plus B square equal to 8 square. What is A square from here? It is 2h the whole square plus 2k the whole square equal to 8 square is 64. As we simplify, 2h the whole square is 4h square plus 2k the whole square is 4k square equals to 64. Dividing by 4, I get h square plus k square equal to 16. To find locus, replace h by x and k by y. I get x square plus y square equals to 16 and that is the locus. Question number 6. Find the equation of the locus of a point such that sum of the squares of the distance from the points is equal to 20. Take the moving point as h, k and the two given points as A and B. The question states sum of the, put plus, squares of the squaring, distance from the points. So AP square plus PB square, sum of the squares of the distances from A and B to P equals 20. How to write PA square? Let us use distance formula. H minus 3 the whole square plus K minus 5 the whole square. It is PA square. I need not put square root because it is PA square. Similarly, what is PB square? H minus 1 the whole square plus K minus of minus 1 is plus 1 the whole square equals to 20. Expanding, h minus 3 the whole square, h square minus 6h plus 9, a square minus 2ab plus b square pattern. Similarly, what is k minus 5 the whole square? K square minus 10k plus 25 plus, expand this, h square minus 2h plus 1 plus k square plus 2k plus 1 and the whole thing equals to 20. As we simplify, h square plus h square is 2h square minus 6h minus 2h minus 8h, 9 plus 1 10, k square plus k square 2k square minus 10k plus 2k minus 8k, 25 plus 1 26, bringing 20 to the left, minus 20 equal to 0. Collecting like terms together, we get 2h square plus 2k square minus 8h minus 8k, 10 plus 26, 36 minus 20 plus 16 is 0. Every term is divisible by 2. So let us divide by 2. I get h square plus k square minus 4h minus 4k plus 8 equal to 0. To get the locus, replace h by x and k by y. So we get the required locus is x square plus y square minus 4x minus 4y plus 8 equal to 0 is the locus of moving point. Question number 7. Find the equation of the locus of the point P such that the line segment joining the points A and B subtends a right angle at P. A, B, the 2 points subtends a right angle. That tells me AP perpendicular to BP. Whenever perpendicular idea comes, I can use Pythagoras theorem. AP square plus PB square equal to AB square, one method. The other method, since I know the points, I can very well use M1, M2 equal to minus 1. What is M1? Slope of AP. How to find slope? Y2 minus Y1 by X2 minus X1. As I know A and P. Y2 minus Y1. K minus of minus 6 by X2 minus X1. H minus 1. Or M1 equals K plus 6 by H minus 1. Similarly, what is slope of BP? Again, this is B, this is P. K minus of minus 2 divided by H minus 4. Or I get K plus 2 by H minus 4. We know M1, M2 equal to minus 1. What is M1? K plus 6 by H minus 1. M2. K plus 2 by H minus 4 equals to minus 1. Multiplying K into K, K square, plus 6K, plus 2K, plus 12, divided by H square, minus H, minus 4H, minus 1 into minus 4, plus 4 equals to minus 1. Bringing them to the other side. What do I get? K square plus 6K plus 2K, 8K plus 12 equals to minus H square. Minus H into minus 1 is plus H, plus 4H, minus 4. Bringing all to the same side, we get K square plus 8K plus 12 plus H square minus H minus 4H plus 4 equal to 0. Or, first let us write H square, then let us write K square, minus H minus 4H minus 5H, 8K, constants together, 12 plus 4, 16 equal to 0. To get locus, replace H by X and K by Y. We get X square plus Y square minus 5X plus 8Y plus 16 equal to 0 is the locus. Question number 8. If O is the origin and R is a variable point on Y square equal to 4X, find the equation of the locus of the midpoint of the line segment OR. Given an equation y square equal to 4x, which we have drawn like this. The diagram of it we will learn next year in detail. Given O is the origin, R is a variable point on it. When I know the midpoint, say H, K, how will I get R? See, this is 0, 0. Midpoint is H, K tells me R should be double of it. What is midpoint formula? 0 plus 2H by 2. 0 plus 2K by 2. So, whenever one point is origin, midpoint is H, K, tells me the other point is the double of it. 2H, 2K. So, what is R? It is 2H, 2K. The question says R is a point on the line. What do you mean by point on something? A point on a particular curve tells me it must satisfy the equation. So wherever y comes, put 2k. So 2k the whole square equals 4 into x is 2h, or 2k the whole square is 4k square equals to 4 into 2h. 4 can get cancelled. I am left with k square equal to 2h. For finding locus, replace h by x and k by y. So it is y square equals to 2x, and that is the locus.